Hello students, today I am going to explain the topic Motional EMF and Fleming's right hand rule. Motional EMF and Fleming's right hand rule. First of all, I am going to describe what is motional EMF. Motional. Motional EMF due to motion. EMF due to motion. The EMF that is generated due to motion of the conductor placed in the magnetic field. It's called motional EMF, where a conductor is placed in a magnetic field and it is moved from one side to another side. Then magnetic flux link with closed circuit change. So an EMF is generated according to the Faraday first law. What is Faraday first law? According to Faraday first law, when magnetic flux link with closed circuit change, then an EMF or an current is induced in the circuit. It is called the Faraday first law. So, motional EMF is the EMF generated due to the motion of the conductor placed in magnetic field. Okay, students. What is Fleming's right hand rule? According to the Fleming's right hand rule, if any closed circuit, if the thumb represents the motion of the conductor, direction of the motion of the conductor or force, and forefinger represents the direction of the magnetic field, then middle finger will represent the direction of the current flowing in that conductor. Again repeating, if thumb represents the direction of the motion of the conductor and forefinger represents the direction of the magnetic field, then our middle finger will represent the direction of the current flowing in that conductor. Okay, student, it is the statement of Fleming's right hand rule. But you can understand Fleming's right hand rule when I am going to explain this with an example. It is the figure. This is the U-shaped railing, and here cross indicates inward magnetic field. PQ is a rod that is placed perpendicularly in the U-shaped railing, and it is also perpendicular to the inward magnetic field. Okay, students, the length of the PQ conductor is L. Suppose PQ conductor is moved towards left with velocity v, then the direction of the conductor is this. My thumb of right hand represents the direction of the motion of the conductor, and my forefinger represents the direction of magnetic field. Then middle finger will represent the this represents the direction of the current. If my thumb if my this if my thumb represents the direction of the motion of the PQ conductor, and this forefinger represents the direction of magnetic field, then middle finger will represent the direction of the current, thumb in the direction of motion, and this forefinger in the direction of magnetic field, and middle finger will represent the direction of the current in that conductor. Okay, student. So it is the direction of the current flowing in the PQ conductor. So it is the direction of the current. It is the direction of the current flowing in this circuit. As we know that if current flows towards this side, this means it is a plus terminal and it is the minus terminal. So EMF generated, the direction of the induced EMF is, this is plus and this is minus. Q is the positive terminal and P is the negative terminal. Okay students, another example I have taken. Please see this. PQ is a rod that is placed perpendicular to the U-shaped railing. Here magnetic field cross indicates the inward magnetic field. Here, the motion of the conductor, the direction of the velocity towards right. So, apply the Fleming's right hand rule to determine the direction of current and the induced EMF. My right hand rule, my right hand thumb in this direction. This is the direction of motion, direction of force or direction of velocity. And this finger, this is my forefinger, it represents the direction of magnetic field inward the plane. Then my middle finger, will represent the direction of flowing current in the circuit. Here it is the thumb that represents the direction of motion of the PQ conductor towards right side, and it is the direction of the magnetic field inward the plane. Then my middle finger represents the direction of the current flowing. So upward direction of the current flowing. So this is the direction of current. If current flowing towards this side means this side. So it is the positive terminal P and here Q is the negative terminal. Okay students. So according to the Fleming's right hand rule, we can decide the direction of motional EMF or motional current. Okay students. Now, what will be the magnitude of induced EMF? It is equal to BLV. Students, B is the magnitude of magnetic field, L is the length of the conductor, and V is the velocity with which conductor moves. Here, EMF is generated only the condition when B, L and V should be mutually perpendicular to each other. Should be mutually perpendicular to each other. Okay students, we can consider that arm SP, SR and SQ. Arm SP, SR and RQ negligible have negligible resistance. So I equal to EMF upon resistance BLV upon R. Okay students, it is the value of induced current. It is the value of induced current and it is the value of induced EMF. Okay students, so it was the concept of Fleming's right hand rule and it was the concept of motional EMF according to the direction of motion of the conductor and the direction of the magnetic field. The direction of induced current will be changed or direction of the induced EMF will be changed. So direction of induced current or EMF totally depends on the direction of the motion of the conductor, and also magnetic field. Okay students, if you have any doubt in your mind, you can ask or comment on my video, and please like and subscribe my channel. Bye bye.